This video will give an introduction to the Magnetic White Blood Cell Engineering Design Challenge. First, let's start with an overview of the design process. This process will help you be the engineer and guide you in solving design challenges. The first step of the process is to identify the problem. What is it that you're trying to solve? Once you decide what the problem is, you can then design a solution by drawing it out with pencil and paper. Once you have a design, you can begin to build it. Once built, you can test your design and see how it works. But wait, you are not done here. Now you identify what went well with your design and what can be improved. Then redesign, rebuild, and retest. What is the problem in the Magnetic White Blood Cell Challenge? Well, you have to determine a way to separate white blood cells from other cells in the blood so that they can be studied. At the lab at Ohio State, we use antibodies to attach really small magnets to the white blood cells in order to sort them from circulating tumor cells. In this design challenge, the white blood cell is represented by this styrofoam ball. And the really small magnets are represented by these magnets in the ice cube trays. You will be designing the antibodies that attach these two things. The primary goal will be to make a magnetic cell by designing antibodies that will pick up the magnets from the ice cube trays. You will want to pick up as many magnets as possible, but you are only allowed to have one magnet per antibody you create. Something to keep in mind as you are designing your antibodies is that they must be long enough to reach down into the ice cube tray to pick up the magnet from the bottom. Once you have completed your design and built your cell with the antibodies, it is time to test. Take your cell to the antibody testing station and hover it over the ice cube trays. Make sure to keep the ball above the testing line. And remember, you can only pick up one magnet per antibody you create. When you have picked up as many magnets as possible, count how many you have and write it down on your paper. Then, return the magnets to the testing station so that others can test. Now, can you think of ways to make your design better? Identify what you could do, then redesign, rebuild, and retest. What will you engineer?